Hi everyone, this is Raju from Smart AI Technologies. Welcome back. If you are new to our channel, we provide free courses and technical support to students. So we made so many videos which can help you to improve your skill or to learn new stuffs in machine learning, deep learning, and AI. So you can go and watch those videos. So this is a fourth part of data analysis using Excel. So in this part, we are going to see data analysis. In the previous part 1, 2, and 3, we done data cleaning. So now we are going to do data analysis. In the data analysis, first we are going to take descriptive analysis. Under descriptive analysis, we are going to implement central tendency, variability, and distribution. Using these three techniques, how do we do analysis? Okay, so how we can do better analysis with help of central tendency, variability, and distribution, and what are they? Okay, now first we'll take up central tendency. Central tendency will give us the average, the center value in any variable or any column. For example, if I take salary and if I detect what is the mean of that salary, that means the average, what is the most repeated or average value. So if 35 employees are there in our data set, what is the average salary of 35 employees? Okay, someone are earning more than that, someone are earning less than that, but what is the average? Okay, that we call it as a mean. And then what is the median and what is the mode, how to implement it, we'll see. Okay, then we'll go for variability, and then we'll go for distribution. Okay, don't miss and don't skip. We'll discuss it one by one and we'll implement it on the data set which you can see on the screen. First we'll take up center tendency under that mean. So for to detect the mean, what we need to do, we have a function called average. You need to write equal to average. After that you need to select the data on which it should detect average. So in my case, I'll try to remove it. Okay, so now, and after writing the average in bracket, I'm going to select this salary, the range what we call. Okay, so select the range, then click enter. So this is the mean salary. Okay, then what is the median? Okay, median nothing but if we have some data, say let us say salary or age. Okay, especially I'm taking age for this median. So now how to detect the median of age is, first arrange that ascending order, then from top and the bottom, it means from lower side and the highest age side. If you move to center, the center value we call it as a median. Then there is a third value called mode. What is this mode is, if I take experience or experience column values, which is repeated more times, 2 is repeated more times, 1 2 3 3 times, so it is repeated more times, and mode of this age column is 2. This is what mean, median, and mode will say. Okay, so what is the average and which is repeated more times, and what is the center value? Okay, for that I have one image. Okay, to showcase what is median and mode, so that you can see here. Okay, there is a course code detail 1 3 4 6 6 7 8. Okay, it's already arranged in ascending order. So what does the mean? You sum of all the element divided by total number of element, that is mean. You will get 5. What is mode? From right side and left side you come to center, the center value is 6, so mode is 6. But sorry, the mode is the most repeated, 6 is repeated twice. Sorry, median nothing but come from both the sides, the center value we call it as a median. What is the range? Okay, that we'll discuss down. Okay, range nothing but the maximum minus the minimum, we call that as a range of values. So you need to take you need to keep these insights with you, these analysis with you. For example, when it comes to this data set, I can say the average salary in that company is 20 lakh. Okay, so the median age will give me one insight, that the company where the people are working, their average age is around 29 30, like the 29. So they are very young. So whatever the company will decide, it may take some decisions, it should consider these things, the age and also the experience. Again, the experience comes in hand. The most people are having around 2 to 3 stuff. Okay, 2 or like the 2 years experience, uh, like freshers are not many and highly experienced are not many. There are, but uh, what this module says, this 2 year experienced people are more compared to other. Even you can take average of that mean of that age, mean of that experience column also, then it will be very proper. So this is the way of analyzing what is the average, what is the concentrated reason, or we can say what data is more, then the decision taking will be very proper. For example, let us say a company which want to host a program. So in that program there are some different groups. Okay, so they are taking three tasks, okay, in that program. So which task should be provided to whom, and which age category are more, which type of experienced people are more. Based on that they will decide, they will try to concentrate more on this class, because they should concentrate on this class, because if they miss here, okay, if they concentrate on some other class where there are so less number of employees, so these people may feel bad. Something, okay, this is not about, like, I'm trying to generalize this. Okay, if you have a employee data set, it's like that. If you have some other data set, it will be different, the way of analysis is different. But there also mean, median and mode, that is central tendency parameters, will come in act, and they are very useful during the analysis. Then comes the second type of analytic things, that is variability. What are the variables are there and what they imply? So we see the range, variance and standard deviations are the three important variables. And one thing I want to mention here, so we are moving in a proper structured way. So we done the data cleaning, now we are doing data analysis. After this we will go for data visualization. So if you see any courses, they will try to teach you functions separately and these things separately, okay, they don't follow a proper path. So if you know 1,000 things, if you don't know how to structure it, it will be very hard, because there are so many functions. Okay, there are so many functions, but they can be used or cannot be used. Sometimes you learn all the functions, but you don't know where to implement, how to implement, when to implement. It will be very difficult for you to do, because if you are given a project, they need step by step analysis what they want. Okay, if you give step by step analysis or step by step process clear to the company, okay, it will be very easy for them to go with the results. Otherwise, in the first case, before doing data cleaning, you directly go for data analysis, and you feel like you are expert in functions and you want to apply all the available functions. It's not like that. Okay, you may bring some results, but you need to follow some steps or structures, then only you'll get some good results. Okay, so don't skip any video. If you missed our previous 3 videos, you can go back and watch them and then come here. Okay, so you will be able to see, able to understand everything clearly, okay, what we are trying to do, because data analysis or data science is having a life cycle. That's based on a life cycle. So the next one step depends on other. Okay, you can mix up, okay, no problem, but that's not the way. If you follow proper life cycle of a data science, okay, if you go step by step, okay, sometimes what will happen, we may use same function in data cleaning and data analysis, but the use case will be different, the purpose will be different. Okay, if you normally study function separately, you will know only function in one way. For example, data cleaning or data analysis, if you know mean function, normally if you study mean function as a separate function, okay, you know what is the use of mean. So you may apply only in one case, not in both the cases. As for my experience, I'm saying this. So we need to understand, okay, where to use, how to use and when to use the proper functions. In the end, in our course, in this only data analysis only, we will keep some extra functions separately, because they, you can use them, okay, you can use them anyway. I will say, okay, they, them particularly those functions I kept in the end. A special function they are kept in the end. First you need to know the process, so I'm using the most important functions which you must and should need to use during the data analysis. So here you can see range. What is the range? Range is the value difference between the maximum value and the minimum value. For that, how to write a function equal to max is a function. So you need to select the range again, okay, and minus minimum, then go and select the range in the column, okay. So once if you enter, it will give the difference between the maximum value and the minimum value. And there comes the variance. What is this variance and what is the equation and what does this imply? So this variance is nothing but the squared difference between the mean value and the real value. For example, to keep it very simple, what this says is, for example, I have this age class. Okay, this age I am having. So I will take average of this age. Average may come around 29 or like that. Okay, now what I will do, if I want to know the variance, what I will do is x minus 28 minus 29. Okay, 28 minus 29 whole square divided by total number of years 35 minus 1. N minus 1 you need to do in the down. Okay, here is the equation. So 35 minus 1. If you do like that, you will get a variance. This variance will say what is the difference between the mean value and the real value. What is different? Like what average age is 29. How much different this person age is from the average age? Okay, so for this we try to use a variance. So how to find out the variance? How to calculate the variance? For that, what is a function? So to calculate the variance, there is a function called VAR. So VAR, within that select the range. Okay, then it will give you a variance. Then comes the standard deviation. For standard deviation, the equation is very simple again. But what is the small difference between the standard deviation and the variance? Variance is the squared function of standard deviation. Again, that standard deviation and variance are almost same. But when you square the standard deviation, you will get the variance. This also implies what is the difference? What is the difference of the value from the mean value, the average value? So what should be their value? Okay, it depends on the thing. For example, we consider normal distribution curves. Okay, so here you see how this normal distribution curves will be. Okay, it will be like this. So when you draw the data, okay, so we call that as an histogram. You can see here I drawn one histogram. It will be like this. For example, when I draw the age details, okay, x-axis will be age, y-axis will be how many people are there in that age. Okay, so it's a histograms. Okay, if you draw it in a line, continuous line, how it will be is like this. So it will be like this. Okay, it's like this, whatever you are saying, and then it's dropping. The mean value will be here, the center. Okay, in our case the mean value will be here, the average age will be here. Okay, the variance will and standard deviation will try to give us the difference between this and the real value. Okay, the difference between the normal age and the present age. What is the difference? Okay, this need to be small. We need to try our level best to keep it small. About this we will study further, okay, using some other variables also, but using variance and standard deviation we will understand what is the difference, what is the distance between our center point, okay, mean and the present value. So we need to reduce this. Why we need to reduce this is our data should be normally distributed. How much our data will be normally distributed, the distance between this will be reduced. So if you are normal distributed data, your models, if in the end if you feed this to your data engineer, if they build some model, they will get better accuracies. The variation should not be very high. This is our purpose. Okay, so that's why we are trying to keep this variance and standard deviation very less as much as possible. And the last or the third part is distribution. Based on the distributions, what you will do, how you will analyze. Okay, for what are the things you are using for analyzing? Histogram, skewness, and kurtosis. What are these? First of all, we will understand what is histogram. You can see. Okay, so this is the histogram. For example, histogram nothing but okay. In my case, what histogram I drawn is, I drawn age and which age is repeated. For example, age 5 is repeated two times. Okay, age 20 is repeated. Age 2 is not practically available. Okay, age 25 is repeated two times. Age 30 is repeated 10 times. Like this, if I go on plotting it, age 50 and 60 will be very less. Again, it will reduce here. So this will come like this. Histogram will come like this. So how to plot it on some columns in our Excel, which I am plotting here. So how to plot it is, for example, uh, this is one graph. Okay, that is here. Now how I will do it, I will show you. You need to have two things first. Bins nothing but the spaces in your axis. Bins and also frequencies. How many values are there? Okay, you need to create first. So when it comes to bins, if I am taking, let's say experience, I'm taking experience column. So I'll take bins as 1, 2, 3. I'll select this. I'll select this. And I'll go for 10. So how long you should move based on the maximum? What is the maximum value? So before plotting the histogram, you need to see the max. What is the maximum value in the experience? So move here, write max, and then you go to this experience column, select all the element in the hand, and if you do enter, 27 is the maximum experience person. 27 years experience employee is the maximum experience employee in your company. So I will select this data. I need to write it till 27. Okay, 27 years data. So now how I need to check what is the repeated, like 1 year experience, how many are there, 2 year experience, how many are there. So equal to, I will use a function called frequency. Okay, so this frequency, what it needs, data array it needs. Which data you want to find the frequencies? For that you need to go here. So experience, I want to take this. So I consider everything. Okay, come on. Bins array, this one I should take. And then I click enter. What I get? 4 I get. I need to expand it to uh, okay, so all these details you got. Now you need to plot histogram for this. Okay, so when you plot histogram for this, first don't select any data, go to insert, go to chart, first create an empty chart here. Don't select anything, go to insert, go to insert, go to chart, empty chart comes. Okay, when empty chart, you will get an empty chart. You need to right click on it, then you should say select data. So which data you want to feed to this? So you need to select all of this, then come here, select this frequency. Okay, so you can see the graph is updating in the back end. Okay, so now you can click yes. So how this data is, when you see, when you calculate histogram of experience, how it is actually what we discussed, it should be like this, but your data is like this. Okay, so what is this type, what is this problem and how to overcome this, we'll discuss that also. You should overcome this, you need to make it almost near to normalized data. You need to normalize the data, you need to change the data structure. How to do that also we'll discuss now. So this is there. So what we call to this condition and what we need to do now when we get like these conditions. Okay, for that we have a next variables called skewness and kurtosis. What is skewness? Here I gave a diagram. Okay, if the data is left side weighted, it is positive skewed. Okay, if the skewness value is positive, it's not zero. If it's positive, it's right skewness. Okay, so like that, this center one is symmetric distributed. Here skewness will be zero. So when it moves to right, it will be positive. When it moves to left, it will be negative. Okay, so this is like left skewed, right skewed is there, no? So when you have most positive and most negative, you need to understand that your data is skewed data. So what to do to that skewed data, how to change the data is, you need to change the format of the data. There are so many techniques. Okay, if you study in a data science, there are so many techniques to handle this situation. One of the technique we will see is logarithm transformation of the data. So how to do it? Here you see I applied a logarithm. So what you need to do, you need to do log, you need to select that value and say enter. So you get logged data. So this logarithm data. Okay, so like that you need to apply and you need to drag this down. It will logarithm transformation apply on entire salary data. So when you plot histogram of this, it will be near to, okay, it will not be like this, it will be very near to a standard or normal distribution curve, as we were discussing. Okay, this is a way of transforming the data. Even there is a variable called kurtosis. So kurtosis, yeah, one diagram, let me show. So when it comes to kurtosis, it should not be positive, it should not be negative, it should be zero. Okay, here you see first it was positive. Okay, what is that kurtosis and what it will imply, I will tell you first. Actually, using skewness, you studied positive and negative skewness. Okay, using kurtosis, what is it? What is the difference is, if the data is like this, it is left skewed. If the data is like this, it's right skewed. If the data is centered, it's proper. Okay, there is no skewness. But what kurtosis, again, what is the kurtosis condition is, if the data is like this kurtosis value is zero. If the data set is goes above it, okay, and goes below this, above and below, these two are the issues. Okay, so it will be more positive, it will be more negative. So it will be zero if you have normal distribution. So we need to try to make this zero. For that also logarithmic transformation will be very helpful. So if you do logarithmic transformation on the data, that will help you to overcome this problem. Okay. That you can see here, skewed on changed data, that is logarithmically changed data, skewness reduced. Okay, kurtosis, it's less negative than more positive. This is the way of solving the problem, this is the way of analyzing the data. And also you may feel here also we are doing little bit cleaning, but it's transforming the data. Instead of cleaning, I can say transforming the data. We are trying to transform the data to get better result or to get better analysis or meaningful analysis. This was all about today. In the next class we will take up the next part of data analysis. Thank you for watching, and don't forget to click on subscribe button and the bell icon so that you will be notified whenever we come up with a new video. Thank you very much.